In the last video, we talked about how to go about naming epoxides using systematic names based on the IUPAC system. In this video, our focus is on the common names of epoxides. How do we go about taking simple epoxides and coming up with common names for them? So let's go ahead and take a look at that. In general, when we think of epoxide functional groups, the origin of an epoxide functional group synthetically is that alkene groups are generally oxidized to give epoxide products. The reason I'm mentioning this right now, rather than saving it for one or two videos down the road where we're looking at reactions that yield epoxides, is because this is the origin of the names of epoxides. The common names of epoxides are based upon the alkene that was used to generate the epoxide group. Specifically, when we are coming up with a general rule for developing the common names of epoxides, we name epoxides as alkene oxides, where the alkene word here is replaced with the exact structure of the alkene that was used to create the epoxide. And the word oxide here infers that the alkene group carbon-carbon double bond has been replaced with an epoxide ring. So the oxide there refers to the three-membered ring that resulted from wherever in the chain the alkene group was. So the word oxide there, subsequent to the word alkene, refers to the fact that the alkene group has become an oxide, an epoxide group, due to the common way of synthesizing these epoxide molecules. So let's take a look at an example here. In fact, what we will do is we will just go ahead and name that structure that I drew up top here. And since we're focusing on common colloquial names for these molecules, we're not going to go into the details of assigning RS configurations and things like that. Generally, with these common names, we're working with relatively simplistic scenarios for epoxides and scenarios where generally the configuration is not expressed. So in this example problem, if we think about the fact that the epoxide group derives from taking an alkene and converting it into this three-membered ring of the epoxide, what we can envision is that the origin of the epoxide group there was from a 4-carbon alkene with the carbon-carbon double bond at position 2 of the chain to give the epoxide starting at position 2. So the common name for the epoxide that we have shown here on the right middle side of the page, right here, would be referred to as 2-butene oxide. So don't be tricked into thinking that just because this has the ene suffix that the structure you draw will have a double bond somewhere in it. That's not the case, because the alkene group there in the ene is tagged with that term epoxide. When you see ene oxide, that is your indication that the molecule is an epoxide. Let's now take a look at this example. We have a 6-membered ring connected to the epoxide group. The common name for this molecule, keeping in mind that the first part of the common name indicates the alkene that was used to create the epoxide, so cyclohexene, because we envision thinking backwards here that this would have been an alkene group that gives rise to the epoxide, so cyclohexene, and then the term oxide designates that the alkene group has become an epoxide. We'll do one additional example here just to finalize this concept, drawing out my epoxide here. So for this particular epoxide, if we were coming up with a common name for this, thinking about our name of the alkene that would correspond to this, we'll make our 4 carbons of the chain inward like this to 5, 6, 7, 8. And therefore, the alkene name that would have gone with this would have been 2-methyl, because at carbon number 2, there's that methyl group. So 2-methyl, and then 8 carbons, so oct 4-ene, because the alkene group would have started at carbon number 4 here. And then the term oxide after that is going to indicate that the alkene group has become a epoxide. So this is your summary of how to go about determining the common names for epoxides. You should be able to either take a name and convert it into a structure, or take a structure that you're given like we've done here and convert it into a common name at this point.